In this video, we will be finding the inverse of a matrix. So in this scenario, we have the matrix 3, 0, 4, 2, negative 1, 3, negative 3, 2, negative 5. This to the power of negative 1 is symbolizing the inverse. We used this in our previous videos for finding the equations of ellipses, circles, and parabolas. So to find the inverse of a matrix, we first set the matrix. Then we will take an identity matrix. The identity matrix is 1, 0, 0, 0, 1, 0, and 0, 0, 1. Our objective is to make this right side come here. So we're going to make our left side look like our right side. Okay, so that is our goal. So we're going to do different transformations and changes to this in order to make it look like our right side, our identity matrix. This is called an identity matrix. All right, so now we will just rewrite it one more time. Okay, and we're going to set it equal to our right side. Okay, so now the first change that we will do here is, so I'm going to look at this 3, and we want to make it equal to 1. So in my thought process, I think that 3 minus 2 is 1. So we're going to label our rows. So this is row 1, this is row 2, and this is row 3. So when doing this, we're going to do row 1 minus row 2 equals row 1. And since our change is taking place in the first row, you can see we wrote it in line with our first row. So now, with the changes, we're going to make our new matrix. So what I like to do personally is, since our change is only going to be taking place in row 1, we can just write in row 2 and row 3. So we have 2, negative 1, 3, negative 3, 2, negative 5, 0, 1, 0, 0, 0, 1. So you can see that row 2 and 3 is left unchanged. So we have row 1 minus row 2. So what I like to do is I like to take our numbers. So our first row that we're subtracting from is 3, 0, 4. Okay? And then our second row, so we're subtracting row 2 from row 1. Our second row is 2, negative 1, 3. So we're subtracting. So now we have 4 minus 3, which is 1. 0 minus a negative 1 is just 0 plus 1 is 1. And 3 minus 2 is 1. So our left side of our matrix is now equal to, our first row is 1, 1, 1. And remember, what we do to our left side, we also have to do to our right side. So now we're going to do the same thing we just did. We have 1, 0, 0 originally for our first row, and we're subtracting our second row, which is 0, 1, 0. 0 minus 0 is 0. 0 minus 1 is negative 1. And 1 minus 0 is 1. So we're just going to write that up here. 1, negative 1, 0. So that is our updated matrix. Next, we are going to do R2 minus 2R1 equals R2. And so here, we are going to write this in line with our second row, since that's what is going to be changed. And again, we can do the same thing where the row that's being changed will be left blank, and we can write the rows that are not being changed. In this case, our first and third row are not being changed. So we have 1, 1, 1, 1, negative 1, 0, negative 3, 2, negative 5, 0, 0, 1. Okay, so now we have to make our change to our second row. So we have row 2 minus 2R1. So let's start out with writing row 2. Row 2 is 2, negative 1, 3. So this 2R1 is just multiplying our first row by 2, and then we're subtracting it from our row 2. So our original R1 is 1, 1, 1, as seen right here. So we have 1, 1, 1, and we're going to multiply each of these by 2. So 2 times 1 is 2, 2 times 1 is 2, and 2 times 1 is 2. So we're going to subtract this 2, 2, 2 from 2, negative 1, 3. So we have 2, 2, 2. 3 minus 2 is 1, negative 1 minus 2 is negative 3, and 2 minus 2 is 0. So this is our updated second row on our left side. So we have 0, negative 3, 1. Then we're going to do our right side, which we're doing row 2 minus row 1, and our original row 2 is 0, 1, 0, as seen right here. And again, we're going to be multiplying our first row by 2. So we have 1, negative 1, and 0, as seen right here. And we're going to be multiplying each of these by 2. 2, 2, and 2. So we have 2 times 0, which is 0. 2 times negative 1 is negative 2. And 2 times 2 is 2. And again, we're subtracting, so it's going to be 0 minus 2, 1 minus negative 2, and 0 minus 0. And again, we got these numbers from down here. And so this is now the next thing we're going to do. So 0 minus 0 is 0. 0 minus minus 2. The minus minus becomes a positive, so it's just 1 plus 2, which is 3. And 0 minus 2 is negative 2. So this is going to be our updated second row on the right side. So we have negative 2, 3, 0. And again, just to recap, we first looked at the transformation that we're making. Okay? And our objective for this transformation was to make this 0 as we want to make our left side look like our right side. So now what we did is we took our second row right from right here, we wrote it right here. Then we took 2 times our row 1, which is 1, 1, 1, and we subtracted that. We multiplied that by 2 and subtracted that from our row 2, as seen here. Same thing we did for the right side. We took our row 2, which was originally 0, 1, 0. We multiplied our row 1 by 2 right here, and we subtracted that from our row 2, 0, 1, 0. And then these changes were reflected in this updated matrix right here. Let's go on to our next step, which in this case, I think we should do R3 plus 3R1. Alright, and so that's going to equal 3 row 3. So again, only thing that's being changed in this transformation is row 3. So we have 1, 1, 1, 0, negative 3, 1, 1, negative 1, 0, negative 2, 3, 0, and we're going to leave our third row blank because that's what's being changed. So again, we're going to write row 3, which was originally negative 3, 2, negative 5. So we have negative 3, 2, negative 5. Okay, and then we're going to be getting our first row and multiplying it by 3. So in this case, our first row is 1, 1, 1. So we have 1, 1, 1 times 3. So each of these are being multiplied by 3. So 3 times 1 is 3. 3 times 1 is 3. And again, 3 times 1 is 3. So we're going to be adding this time. So we have negative 3 plus 3, 2 plus 3, negative 5 plus 3. So simple addition here. Negative 5 plus 3 is negative 2. 2 plus 3 is 5. And negative 3 plus 3 is 0. So this is going to be our updated third row. So we have 0, 5, negative 2. And again, now we have to do our right side. And so we're going to take our original third row, which is 0, 0, 1. So we're going to write that right here, 0, 0, 1. 0, 0, 1. And then we're going to take our first row, which is 1, negative 1, 0. Same thing here. And we're going to be multiplying that by 3. So 1, negative 1, 0, all times 3. 3 times 0 is 0. 3 times negative 1 is negative 3, and 3 times 3 is 3. So here we're adding, so we have that. So we have 0 plus 3, 0 minus 3, and 0 plus 0. These numbers were taken from right here. So 1 plus 0 is 1, 0 plus negative 3 is negative 3, and 0 plus 3 is 3. This is going to be our updated third row. So we have 3, negative 3, and 1. Next, we're going to have the transformation R1 minus 1/5 R3 equals R1. And again, forgot to do this here, but we're going to move this down since our transformation is taking place in row 3. And we're going to move this one up since our transformation is going to affect row 1. So now we're going to write our next matrix. Just quickly, I'll make this smaller so we have more space. Same goes for this guy here. Okay, so next we have our next matrix, and we're changing row 1, so we're going to leave it blank. So we have 0, -3, 1, 0, 5, -2. We have our right side of -2, 3, 0, 3, -3, 1. And again, these numbers are coming from our last matrix. Since we're changing row 1, I've left it blank so we can write in the new changes. So we have row 1 minus 1/5 of row 3. So let's write out row 1 first. So we have original row 1 of 1, 1, 1, 1, 1, 1. And we're subtracting that from 1/5 of 0, 5, -2. So let's just do that really quickly. So we have 1/5 times 0, 5, -2. Each are being multiplied by 1 over 5, 1 over 5, and 1 over 5. So here we have 0 times 1 over 5, and then that's 0. 5 times 1 over 5 is just 1, and -2 times 1 over 5 is just -2 over 5. You can think about it like this. -2 is basically just -2 over 1, right? And that's being multiplied by 1 over 5. So now our denominator stays as 5, our numerator is just getting multiplied by -2, so that gives us this fraction of -2 as seen here. That's just the best way of thinking of multiplying fractions. And in this case, it's a whole number multiplied by a fraction. So this is our resulting 1/5 of row 3, which we are going to be subtracting from row 1. So again, we've written row 1 up here, and we have 1, 1, 1. So 1 minus 0, 1 minus 1, and 1 minus -2 over 5. So this is just going to become 1 minus -2 over 5, which is just 1 and 2 over 5. Or you could write it as 7 over 5. Here, 1 minus 1 is 0, and 1 minus 0 is just 1. So we have 1, 0, and 7/5. So we're going to write that up here. So we have 1, 0, and 7 over 5. Then we're going to do the same transformation to our right side. Okay, so just for the ease of things, I'll make this all smaller. And then we have our right side, which is row, we're going to get row 1, which is 1, -1, and 0. And we're subtracting that from 1/5 times row 3. In this case, we have 3, -3, and 1, all being multiplied by 1 over 5. So we're just going to write that out down here. So we have 1/5 times 1 is just 1/5. -3 times 1 over 5 is -3 over 5. And 3 times 1 over 5 is just 3 over 5. So this is our resulting row 3, which we're going to subtract from our row 1. So we have row 1, which is 1, -1, 0. And we're subtracting 3 over 5, -3 over 5, and 1 over 5. So 0 minus 1 over 5 is -1 over 5. -1 minus -3 over 5 is just -1 plus 3 over 5, which leaves us with -2 over 5. Then we have 1 minus 3 over 5, which is just 2 over 5. Okay? And that's going to be our resulting row 1. So we have 2 over 5, -2 over 5, and -1 over 5. Okay? Next, we are going to be doing our next transformation, which is going to be R2 plus 4 over 5 R3. So again, we can just make everything smaller and move it to one side, so we have enough space to complete our matrix. So again, I said we're going to do our next transformation of R2 plus 4 over 5 R3. 3. Okay? Only row, and that's all going to equal R2. So the row that's being changed is R2. So we would, oopsie daisy, we would bring this guy down, and we would write our transformation in line with R2. So since R2 is the only row being changed, we'll write all our other rows in. In this case, 0, 5, negative 2, 3, negative 3, 1, 1, 0, 7 over 5, 2 over 5, negative 2 over 5, and negative 1 over 5. Next, what we will do is complete our transformation. So we're going to write out row 2, and row 2, as you can see right here, was 0, negative 3, 1, right? And then we're going to take 4/5 of row 3. So row 3 is right here, and row 3, so we're going to just do that down here. So we have 0, 5, negative 2, multiplied by 4 over 5, 4 over 5, and 4 over 5. So in this case, we have 0 times 4 over 5, which is 0, 5 times 4 over 5, which is just 4, and 4 over 5 times negative 2. Remember, it's just over 1, so we have negative 8 over 5. So this is our resulting row 3, which we are going to be adding to our row 2. So we have 0, 4, negative 8 over 5. So we have 0 plus 0 is 0. Negative 3 plus 4 is 1. And 1 minus 8 over 5 is negative 3 over 5. Okay? So that's going to be our resulting row 2. 0, 1, negative 3 over 5. It's going to be our resulting row 2, and now we're going to do our right side. So we're going to have row 2 again. So it's going to be our right side row 2, which is negative 2, 3, and 0. So we have negative 2, 3, and 0. That's going to be added to 4/5 of row 3, and row 3 is 3, negative 3, 1. So we're going to take 4/5 times 3, negative 3, and 1, 4 over 5, 4 over 5, and 4 over 5, multiplying. And so we get 4 over 5 4 over 5, negative 12 over 5, and 12 over 5. It's going to be our resulting row 3. So we have 12 over 5, negative 12 over 5, and 4 over 5. Okay, then what we are going to do is add both rows. So we have 0 plus 4 over 5, which is 4 over 5, 3 minus 12 over 5, which is 3 over 5, and negative 2 plus 12 over 5, which is 2 over 5. This is going to become our resulting row 2. So we have 2 over 5, 3 over 5, and 4 over 5. So now you can see that we are almost reaching our goal in that this 1 has become a 1, this has become a 0, we have zeros down here, and our middle term in our second row is 1. So now the only changes we still need to make is try to make this 7 over 5 a 0, this negative 3 over 5 a 0, this 5 a 0, and this negative 2 into a positive 1. So the next step I think we should take is doing R3 minus 5R2. So now we have R3, and we can see here R3 is 0, 5, negative 2. So we have 0, 5, negative 2. That's going to be subtracted by 5 times R2. And R2 was 0, 1, negative 3 over 5. So I'm going to do that down here. 0, 1, negative 3 over 5, all being multiplied by 5. 5 times 0 is 0. 5 times 1 is 5. 5 times negative 3 over 5 is negative 15 over 5, which is just negative 3. So this is going to be subtracted from 0, 5, negative 2. So we have 0, 5, negative 2 subtracted. We're subtracting 0, 5, negative 3. So negative 2 minus minus 3 is just negative 2 plus 3, which is 1. 5 minus 5 is 0, and 0 minus 0 is 0. So we have our new third row. This is all equal row 3. So we have a new third row of 0, 0, 1. We're going to still write our second row and first row since they haven't been changed. 0, 1, negative 3 over 5, 1, 0, 7 over 5. Then our right side, now we're going to rewrite our first and second row since those aren't being changed. So it's 2 over 5, negative 2 over 5, negative 1 over 5. Then we're going to rewrite our second row, which is 2 over 5, 3 over 5, and 4 over 5. So we can just make those a little smaller so they all fit. All right. And now we're going to do the same change we made to our left side onto our right side. So we're going to take our original row 3, which is 3, negative 3, 1. So we're just going to write that right here. 3, negative 3, 1. That's all going to be subtracted by 5 times row 2. And as written here, row 2 is 2/5, 3/5, and 4/5. So 5, 5, and 5 being multiplied by 2 over 5, 3 over 5, and 4 over 5. 4 over 5 times 5 is just 4, because 5 times 4 is 20, and 20 divided by 5 is 4. So then 5 times 3 is just 3, and 5 times 2 is just 2. So that's what's going to be subtracted from 3, negative 3, 1. So we have 2, 3, 4. 1 minus 4 is negative 3. Negative 3 minus 3 is negative 6. And 3 minus 2 is 1. This is going to be our resulting row 3. So we have 1, negative 6, negative 3. Again, you can see our left side is taking more shape of our identity matrix as we wanted. Our last row has become perfect. This first column has become perfect, and our second column has become perfect. Only thing we need to change is make the 7/5 a 0 and this negative 3 over 5 a 0. That is what we are going to attempt to do in our next couple of steps. Now we are going to do our next step, and our next step is going to be R2 plus 3 over 5 R3, and that's going to be equal to R2, and we can see that's in line with row 2. So let's start drawing our matrix. And the only row that's changing is row 2, so we can just rewrite row 1 and row 3. So we have 1, 0, 7 over 5, and then we have 2 over 5, negative 2 over 5, and negative 1 over 5. And for row 3, we have 0, 0, 1, 1, negative 6, negative 3. So now we're going to be changing row 2. So we have row 2, which originally was 0, 1, negative 3 over 5, and we'll just write down below. So we have 0, 1, negative 3 over 5. That's going to be added to 3 over 5 times row 3. Row 3 in this case is 0, 0, 1. So we'll just do that multiplication on the side. So we have 0, 0, 1, all being multiplied by 3 over 5, 3 over 5, and 3 over 5. 0 times 3 over 5 is 0. 0 times 3 over 5 again is 0. 1 times 3 over 5 is 3 over 5. So here we're going to write 0, 0, and 3 over 5, which we just computed for right here. So we have 0 plus 0, 0. 1 plus 0 is 0. Negative 3 over 5 plus 3 over 5 is 0. Next, we're going to take our numbers, write them right here. Next, we have negative 3 over 5 plus 3 over 5, which is 0. We have 1 plus 0, which is 1. And we have 0 plus 0, which is 0. This is going to be our new row 2. So now you can see we're really close to getting our identity matrix on the left side. We just have to make this 7 over 5 0. We'll do that in our next step. Now we're just going to do the transformation to a right side of row 2. So original right side of row 2 was 2 over 5, 3 over 5, and 4 over 5 as seen here. So we're going to write that really quickly. 2 over 5, 3 over 5, and 4 over 5. That's being added to 3 over 5 times row 3. Row 3, as we can see here, is 1, negative 6, and negative 3. So we have 1 times 3 over 5 negative 6 times 3 over 5, and negative 3 times 3 over 5. 3 over 5 times 1 is 3 over 5. Negative 6 times 3 over 5 is negative 18 over 5. And 3 over 5 times negative 3 is negative 9 over 5. These are all going to be added to this upper row. So we have 3 over 5 plus 2 over 5 plus 3 over 5, 3 over 5 plus negative 18 over 5, and 4 over 5 plus negative 9 over 5. So now if we quickly just move this down below, we will do this quick addition. We have 4 minus 9, which is negative 5 over 5, which is also negative 1. 18, so we have 3 minus 18, which is negative 15 over 5, which is just negative 3. And we have 2 over 5 plus 3 over 5, which is just 5 over 5, also known as 1. So our new row 2 on our right side is just 1, negative 3, and negative 1. So 1, negative 3, and negative 1. So now that our bottom two rows, row 2 and row 3, are complete, we just have to worry about the 7 over 5 and make it a 0. So quickly, we're just going to move on to our last step for this matrix to get its identity matrix on the left side, and to find its inverse. We're going to do our last step, which is R1. So we'll write that up here actually. So we have row 1 minus 7 over 5 row 3 equals row 1. So we're just going to draw an arrow. We can do it right here actually. So we're going to start drawing our new matrix. And row 1 is the only row that's being changed in this case. And so row 1 is, we're just going to leave it blank. We're going to do row 2 and row 3. So we have 0, 1, 0, 0, 0, 1. Then on the right side, we have 1, negative 3, negative 1, 1, negative 6, negative 3. Now we're going to compute for row 1. So we're going to do row 1 minus 7 over 5, row 3. So 7 over 5, row 3. So we're going to look at our row 1 originally, which was 1, 0, and 7 over 5. So we're going to write that really quickly. 1, 0, 7 over 5. That's going to be subtracted from 7/5 times row 3. And the row 3 is 0, 0, 1. So we're going to do 0, 0, 1 times 7 over 5. 0 times 7 over 5 is 0. 0 times 7 over 5 is 0. And 1 times 7 over 5 is 7 over 5. So that's going to be subtracted from 1, 0, 7 over 5. So we have 0, 0, 7 over 5. 1 minus 0 is 1. 0 minus 0 is 0. And 7 over 5 minus 7 over 5 is 0. So our resulting row 1 is 1, 0, 0. So our left side is now perfect. Now we're going to be worrying about our right side, and we're almost done with the inverse of this matrix. Next step we're going to do is to write down our row 1. Our row 1 on our right side is 2 over 5, negative 2 over 5, and negative 1 over 5. We're just going to write that down here. So 2 over 5, negative 2 over 5, and negative 1 over 5. Then we're going to be subtracting negative 7/5 of row 3, which is 1, negative 6, negative 3, from this row 1. So we're going to do that really quickly. 1, negative 6, negative 3, all times 7 over 5, 7 over 5, and 7 over 5. So 1 times 7 over 5 is just 7 over 5. 7 over 5 times negative 6 is negative 42 over 5. And 7 over 5 times negative 3 is negative 21 over 5. So then we're just going to be subtracting it from these numbers right here. So subtracting 7 over 5, negative 42 over 5, and negative 21 over 5. We can move this multiplication off to the side. And so now we have negative 1 over 5 minus negative 21 over 5, which is just basically negative 1 over 5 plus 21 over 5, which gives us 20 over 5, which is equal to 4. Then we have negative 2 over 5 minus negative 42 over 5, which is just negative 2 plus 42 over 5, which leaves us with 40 over 5, also known as 8. Then we have 2 over 5 minus 7 over 5, which is negative 5 over 5, which equals negative 1. So we have negative 1, negative 8. Now we have negative 1, 8, and 4, which is going to be our new row 1 on our right side. Negative 1, 8, 4. Now you can see that our left side has become our identity matrix of 1, 0, 0, 0, 0, 1, 0, 0. Now, finally, you can see our left side has become our identity matrix of 1, 0, 0, 0, 1, 0, and 0, 0, 1. This means that we have found the inverse of this matrix. That inverse of the matrix is our right side, which is negative 1, 8, 4, 1, negative 3, 1, negative 1, 1, negative 6, negative 3. This equals the inverse of our original matrix, which was 3, 0, 4, 2, negative 1, 3, negative 3, 2, negative 5. So we can just write it like this. We wrote it down up here. The inverse is going to be equal to what we have down here. So we can just quickly paste that up here. So now this is our identity matrix, and we have successfully found the inverse of this matrix, which is negative 1, 8, 4, 1, negative 3, negative 1, and 1, negative 6, negative 3. Thank you, and I hope this video helps you guys. If this video did help you guys, please subscribe, and please let me know if you have any more video requests in the comments below. Thank you.